Howdy and welcome. It's safe to say that I learned a ton after building my 2JZ about a year ago. I spent a countless amount of time researching parts, processes, and just general information about the build itself. For anyone looking to build their own 2JZ, planning out the build can seem daunting. I would know. I felt the same way when I started. So the goal of this video is to give an inclusive perspective on which parts to buy, reputable places to buy those parts, and the tools needed for the build. Let's get started by diving into the parts that you're gonna need. If you're interested in an engine build video, you can find that in the top right corner. Parts needed. Now let me begin by stating the obvious. No two builds are alike. Everybody has their own goals and budgets, which will dictate the parts that you buy for your build. For this video, I will assume that you are doing a complete rebuild of a stock 2JZ GTE to make a reliable 800 wheel horsepower. However, I will also make sure to list the parts to buy if you're rocking a GE motor. 800 wheel horsepower is enough that you don't need to go crazy with a billet crank, stroker kits, or race port in your head. It will be just a relatively simple build. So let's get started with the rotating assembly. For a theoretical build, we will keep the stock crankshaft. What you need to check for on your crank is that the journals are still in working order. A good crank journal will have no markings and you will be able to drag your fingernail across it and feel absolutely nothing. Here is an example of a good journal, and here is an example of a bad one. If you do have scuff marks, don't fear. What you need to do is take the crank to a machine shop and get a grind and a polish on those journals. Next, let's move on to those beautiful connecting rods. Now for 800 wheel horsepower, you don't really need to change these, unless you have a GE engine, and then these will absolutely need to be changed. So let's say for the sake of this video that you want to get new connecting rods anyways. A great connecting rod that has been proven time and time again by a lot of built Supra owners is Eagle rods. They support a great amount of power, are of good quality, and are a relatively budget option. A little more expensive and higher quality is the Brian Crower rods, and if you want the creme de la creme of connecting rods, you can get Carrillo rods for a whopping $2,100. For our 800 horsepower build, Eagle rods will do just fine. If you do want to stick with the stock GTE con rods, do a general look over to make sure they look okay, and take this time to go ahead and replace your wrist pin bushings because they see a lot of abuse. This is easy. Just pick up a set of 6 bushings and have a machine shop pop the old ones out and install the new ones for you. Pistons are up next, and there are a ton of quality options out there. A majority of people go with CP pistons. They are tried and true and have a phenomenal track record. Manley pistons are also a great option if those CP pistons are on back order. So when you go to order these pistons, you will have a lot of options for the size and compression ratio. The stock 2JZ GTE bore is 86mm and the stock compression ratio is 8.5 to 1. Now this is where it gets a bit hairy. If you need to bore your block 20 thou or 40 thou over, you need to add that to the piston diameter that you're buying. For example, if you are boring your block 20 thou over, that's 20 thousandths of an inch, your bores are now 86.5 millimeters each, so you need 86.5 millimeter pistons. Nice and easy, right? Compression ratio is a little less black and white. Most people stick with 8.5 to 1 compression ratio pistons. However, you can get away with 9 to 1 compression ratio pistons to make a little more power. However, this is also more dangerous on a turbocharged engine. I recommend staying stock at 8.5 to 1, and if you want more power, just buy a bigger turbo. For my GE friends out there, stick with 8.5 to 1 because you can change the compression ratio later on with your head gasket thickness that you choose. Your shiny new pistons will come with a set of wrist pins, so that's one less thing you need to worry about, and they will also come with the piston rings, so you don't need to worry about those either. And just like that, our rotating assembly is complete. Now on to bearings. There are plenty of ways to go about this. Some people swear by using the OEM Toyota bearings because you can buy each bearing independently at a specific size to match the markings on the crankshaft and connecting rod. For those who are unaware, the crankshaft and connecting rods are stamped with a number at the factory. These numbers are added together at each journal to give you the size of the bearing that you need to buy. For example, if your connecting rod has a 1 and your crank has a 2, you need to get a size 3 bearing following this chart here. The part number for the OEM Toyota bearing is shown here, and the bearing size will be dictated by the number after the second dash. For example, this part number shown here has a -03 at the end, so it is a size 3 bearing. This sizing method will not work, however, if you get your crankshaft polished, so you will have to measure each journal independently and buy your bearings accordingly. You can't go off the factory markings. Just to sum up the OEM bearings, they hold up really well to higher horsepower and have a cult-like following of people that refuse to run anything else because OEM quality is the best quality. However, if you do want to go aftermarket, which a lot of people tend to do, you will find that the ACL race bearings are almost always the way to go. King bearings also have a great reputation and are a great choice. I would personally stay away from Clevet bearings as they use a softer metal and are prone to spinning at higher RPMs and horsepowers. Now, sizing for these aftermarket bearings generally goes as follows. They will always have an STD or standard size. They will have two different undersize options. So for ACL race bearings, they have a 10 thousandths undersize and a 1 thousandths undersize. And they will also have an HX or high clearance size. STD is for if your crank has never been touched. The 10 thou and 1 thou undersize is if your crank was ground 10 thou and 1 thou accordingly, and the HX size is only to be used if you are using aluminum rods, which a majority of people are not. However, no matter how sure you are that the bearings you bought are the right size, double check the clearances when you assemble the engine. More than once, I've heard tons of stories of people that don't double check their clearances and then they end up grenading their motor. Now, for anybody that needs to take their block to a machine shop, here's what you need to know. First, everything needs to be disassembled. Unless the machine shop is reassembling your motor for you, you should generally go with your block completely disassembled. For this imaginary project, we just want them to work on the block, so it must be bare. If they are boring your block, it is super important that you ask if they have a torque plate for the 2JZ. This, however, is pretty uncommon because most machine shops, at least local to me, deal mostly with V8s and don't have inline 6 torque plates. If they don't have a torque plate, don't fret. Superstore rents out torque plates for you to give to the machine shop, so you can go ahead and just do that. The machine shop does not necessarily have to use the torque plate for the boring process, but they do need to use it at the very least for the honing process, which is the final step to boring out your block and serves to prep the piston walls for the piston rings. Essentially, honing removes a very small amount of material by precisely scuffing the sides of the piston walls in a configuration that allows proper lubrication of the piston rings during operation. You can then ask the shop to resurface your block, and make sure to ask them to keep a note of how much material they took off the block. This is so that you can properly size your head gasket thickness later on. You also need to ask the machine shop to remove all your freeze plugs and oil galley plugs. This is because when you get the block hot tanked, which is a cleaning process for the block, basically like putting it into a dishwasher, you need to ensure that no metal particulate gets trapped in the oil or coolant passages. My local machine shop refused to remove my oil galley plugs because you need to weld a slide hammer to those little steel balls to remove them, so I had to take the block to another machine shop to get those out prior to taking it back to the first shop and having them machine my block. So after you get all that stuff removed, then you can ask the shop to hot tank your block, which will clean it, and that's it. Congrats, your block is now all finished. Now on to the cylinder head. Upgrading the valve train is not really necessary for 800 wheel horsepower and a stock redline. For a VVTi, the stock redline is 7,200 RPM, and for a non-VVTi, it's 6,800 RPM. But let's say you want to tell everybody about your stage 3 cams and conical valve springs, so let's talk about those upgrades. I'm going to keep this simple and go under the assumption that most people don't have a valve cutting machine in their garage or a resurfacing machine. And with that being the case, you are going to drive either to a local machine shop or shift that cylinder head off to a reputable shop. Now, I'm going to be upfront here and admit that I don't have a ton of knowledge in this area. For my build, I just sent the cylinder head off to Head Games Motorworks, and they recommended valves, springs, buckets, and cams to me based off of my RPM and horsepower goals. However, through my research, I think I can give a pretty good idea of what brands are reputable. So for valves, you really can't go wrong with any of the big names. GSC, BC, Farah, Manley, they are all pretty darn good. Now, like bearings, there are size options for valves too. You've got STD, which is standard, 1mm oversize on both valves, 1mm oversize on just the intake, and 1mm oversize on just the exhaust. If you're looking to make over 1,000 wheel horsepower, oversized valves may be the way to go. However, for our power goals, STD will do just fine. As for springs and retainers, the same rules apply. Any big name company is going to be a good choice. As for the type of spring that you get, that is more up to debate. In my research, Brian Crower single springs are the way to go for 500 to 700 wheel horsepower. If you want to step that up a notch, GSC conical springs are a good option for a higher redline, as the conical spring design helps dampen the coil resonation. A step further would be the GSC dual spring, which further helps to dampen coil res. However, it will add more wear to your valve train because it weighs more than the other spring types. What type you choose is up to you. I went with the GSC conical springs for my build and plan to have an 8,500 RPM redline. The retainers are easy because they almost always come with the valves. So next up is the buckets that you're going to use. The 2JZ comes stock with shimmed buckets, meaning the bucket that the camshaft lope presses down on has a removable shim on the top to make it easy to set valve lash. Valve lash is just the distance from the base circle of the cam lope to the bucket. For high RPM builds, it's very common to get shimless buckets, which have no removable shim, and each bucket is a different size to properly set valve lash. If you want to get shimless buckets and do a DIY conversion, that is somewhat tedious and a lengthy process that I will not be covering in this video for the sake of time. If you do want to do that conversion, most machine shops will offer it for you, which is what I did. Cams are next on the list, and boy do you have some options. Stock cams are more than fine for this horsepower, but I know you want that nice lopey idle. So let's talk cams. In general, the more aggressive the cam, the more rough the idle gets because of how much air the cam is forcing the engine to run on. Now you can't go out and just buy a stage 3 cam and call it a day. You need to properly size the cam to fit your power and RPM goals, because without doing this step, you may have a cool idle, but you won't have any beneficial power gains. For an 800 horsepower build and an 8,500 RPM redline, the BC 264 or 272 will do you just fine, along with the GSC Stage 1 or Stage 2 cam. If you want to step up the quality a bit, you can spring for the HKS 272s, but this really isn't necessary. Of all the times I've heard of people snapping cams, it's almost always due to installation error, not the horsepower. Two things to keep in mind. Headwork is not the only variable in dictating the RPM limit. Turbo size also plays a massive role. Another thing to note is that upgrading your cams will almost always ensure that your motor is now an interference motor, meaning that your pistons now have the ability to come in contact with your valves. Now that you have all your parts picked out, you can take your head over to your machine shop and have them do the work and install those parts for you. The machine shop will probably ask you what you want done to the cylinder head, and here is what you can say.
Yeah, so I want a resurfacing job. I'll take a valve job. New guides, shimless buckets. Let's see. New valve stem seals too. Yeah, that'll do it.
What this means is that they will resurface the mating surface on the head for you, along with cutting a 3-angle valve seat for your new valves. They will also install new valve guides. They will install your shimless buckets, and generally they will set the lash as well. And finally, they will throw in some new seals for you. And there you have it. The cylinder head is complete. Just make sure you ask the shop doing the work to take note of how much material they removed during the resurfacing process so you can properly size the head gasket later on. Talking about the head gasket, you need one. It is important. So generally, when you get the head and the block resurfaced, not enough material will be removed that you need to worry about getting a thicker head gasket. The OEM GTE one will work just fine and holds an amazing amount of power. The OEM head gasket is 1.3 millimeters thick for reference. You may be asking, Connor, what is an example of a large or a small amount of material taken off the block or head? Great question. My general rule of thumb is that if below 12 thousandths of material is taken off in total, then the OEM head gasket will work just fine. For my build, the amount of material taken off was around 24 thousandths, which is just about 0.6 millimeters. Therefore, I decided to get an HKS 2mm head gasket to make up for all the material that was removed. Some people just rock the stock head gasket no matter how much material was taken off, and generally these people have no ill effects. But for the most part, most people will not need to worry about getting a different size head gasket, and you can just get the OEM one. For my GE guys out there, you definitely can't rock the stock head gasket. It's not an MLS or multi-layered steel head gasket, and it is really thin. You're gonna need to get a 2.5mm MLS head gasket to drop down that compression ratio so you can make that sweet boost. A lot of companies make great 2.5mm head gaskets. BC, Tomei, Comatech, you can't go wrong with any of those. A little miscellaneous part you need to complete the internals of your built 2JZ are ARP head studs. There's no argument here. If you want power, you need to get the ARP head studs, no questions asked. The last little part that you might need actually resides outside the engine, and it is a billet timing belt tensioner. If you want to bump up your redline, this is definitely a part that you're going to need. This is because the OEM one is prone to snapping at higher RPMs. Drift Motion and Real Street make this product, and you can't go wrong with either of those. So that wraps up the internals of the built 2JZ. There are a million options for what you choose to do outside of the engine. Turbo, injectors, coil packs, manifolds, you name it. This video would be hours long if we got into all that. I would say that for our imaginary build in this video, you can just rock a stock oil pump and throw on an ATI or fluid damper harmonic damper and call it a day. The rest is up to you. Now let's talk where to buy these parts and where to get your services performed. Where to buy. There are a lot of websites where you can buy your engine parts from. Some are scams and some are reputable, so let's go over the best places to buy these parts. The number one place I would recommend to buy your engine parts is Real Street Performance. And no, I'm not affiliated with them in any way, they're just a great company. They have an awesome customer service support line with people who are really knowledgeable about engine builds and are great at making suggestions on which parts to buy based on your goals. They carry just about any part you could need and even make their own custom parts, such as the billet timing belt tensioner we talked about earlier. And like most good companies, they have quick shipping and fairly priced merchandise. Drift Motion is another great company for buying engine parts. Like Real Street, they carry a ton of parts and they make their own custom parts as well. Their customer support isn't as knowledgeable as Real Street's in my opinion, unless you talk to Aaron, who is the CEO of Drift Motion. At the moment, however, their shipping times are rather slow due to the lack of staff and the events that have occurred over the past 2 years. So just keep that in mind. Superstore, Titan Motorsports, and Induction Performance are also all great sites to get your engine parts. You're gonna have to stop by Superstore anyways if you need to rent out that torque plate that we talked about earlier. One place you don't want to buy engine parts from, no matter how small, is eBay. I know this seems kind of obvious, however some people do this to save a couple of bucks and end up getting replica parts. For example, sellers on eBay are notorious in recent years for selling fake OEM Toyota parts that are hard to distinguish from the real thing. This isn't to say that everything you buy off eBay is fake, however, I tend to avoid it wherever I can just to make sure there isn't the opportunity for me to put fake parts on my engine. If you need to buy OEM Toyota parts, I almost always go to the dealership websites to do so, such as ToyotaPartsDeal.com, which carry genuine OEM parts, but I've only really used this site to pick up little things like seals, gaskets, and the like. Now let's talk machine shops a little bit more. I've had such bad luck with poor quality machine shops in the past, so let me share what I have learned. There are a number of reputable 2JZ specific machine shops dotted around the country. For example, Kaizen Motorsports in California, Mazworks in Florida, Superstore in Arizona are all great shops to do any work on your 2JZ. However, most people don't live near one of those shops and will have to take it to a more local shop. I did this and took it to a shop near me that had good reviews and worked mostly on V8s. Here's what I've learned through a ton of research and headaches. 2JZs require a super smooth deck surface with an RA or roughness average of below 20. The lower the number, the smoother the surface. Roughness average is a metric used to basically quantify how smooth a surface is, and it is measured using what's called a profilometer. The surface on the block and the head needs to be extremely smooth due to the use of an MLS head gasket, which doesn't conform to fit all the little peaks and valleys left on a surface after machining. That is why older V8 engines don't require that smooth of a surface, because they mostly use composite head gaskets or softer metals that conform much better to rougher surfaces. So the most important thing you need to make sure of when you go to find your machine shop is that they can put a super smooth surface on your block. I was naive and told the first shop that I went to that I needed a surface suitable for an MLS head gasket. I got the block back and decided to check the RA of the surface because my work had a profilometer. The surface ended up being about 35 RA on average. I then spent a couple of weeks phoning up different shops in my area to see what kind of surface they could put on my block, and ended up finding one in Delaware called Alderman Automotive Machining, which was able to get a 19 RA on my block. I also had the first shop I just talked about resurface my cylinder head, and they put a similar 35 RA surface on it. I ended up taking it to Head Games Motorworks in New Jersey, where after inspecting my head, they informed me that the surface on the cylinder head that the previous shop had put on would never work and I would end up having head gasket problems down the road. Suffice to say, the surface that Head Games Motorworks put on my head was a near polished finish. I didn't even need to get it checked because I knew it was well under 20 RA. It was probably even in the single digits. So to sum up this section, most shops have no problem doing a bore and a hone that is acceptable for a 2JZ. However, it is much harder to find a shop that can put the proper surface on your head and block. So just do your research and find a place that can get that surface super smooth for you. Tools. So you know which parts to buy and where to buy them, but what tools do you actually need to build an engine? I will list the links to all the tools I talk about in the description. So let's jump right into this. First and foremost, you're gonna wanna pick up an engine stand. This is necessary if you're assembling the engine yourself because you need the ability to rotate the engine 180 degrees at different parts of the assembly. To attach the engine to the engine stand, you will need 4 M12 by 1.25mm bolts that are about 3.5 inches long. These are relatively hard bolts to find because M12 bolts usually come in a 1.75mm pitch and not 1.25mm, but if you scour enough hardware stores, you can find them. I found mine at a local Ace Hardware. The most important tool you will need, in my opinion, is a torque wrench. Unfortunately, there's no one size fits all. You will need to purchase probably 2 or 3 different torque wrenches that all have different scales. For example, most of the small stuff in the engine requires units as small as inch-pounds, such as the oil squirters, but the crank pulley bolt requires 240 foot-pounds. So you'll need to purchase a set of torque wrenches that span from inch-pounds to at least 240 foot-pounds. Next up is a piston ring expander. The piston ring expander is to fit the piston rings on the piston. It is a cheap tool and makes installing the piston rings super easy. You'll also need a jeweler's file, feeler gauge, and piston ring filer to properly gap your piston rings. The piston ring filer and feeler gauge are pretty self-explanatory, and the jeweler's file is there so that you can rid the edge of the piston ring of any burrs after you file the ring down. You will also need a piston ring compressor tool to install those pistons into your bores. There are expensive ones out there and cheap ones. I went with one of the cheaper ones and it worked just fine for me. Earlier, we talked about double checking clearances, so here are the tools you need to do that. First, you're gonna wanna check your piston to wall clearance. This ensures that your piston is the proper size for your bore. You will need a dial bore gauge to check the bore diameter and a 3 to 4 inch micrometer to check your piston diameter. The spec sheet that comes with your pistons will tell you the recommended piston to wall clearance. While checking your bore diameter, you can also check the taper and out of roundness of the bore. To do this, you either need to bolt a torque plate or cylinder head onto the block and torque it to spec. From there, you measure the bore at multiple points to make sure the measurements are all within the maximum allotted amount of 0.0008 inches. Yes, that is 0.8 of a thousandth of an inch. You're also going to want to check your bearing clearances for your main and rod bearings. There are 2 ways to go about doing this. You could use a dial bore gauge and a micrometer as we did for the piston and the bores, or you could just use Plasti-Gauge. Plasti-Gauge is a little strip of material that you lay between the journal and the main/rod cap. You then torque the cap down to spec and then you remove the cap. The Plasti-Gauge will smush, and depending on the width of the smushed Plasti-Gauge, that will tell you your clearance. Personally, I tried both methods just for fun. I found the Plasti-Gauge to be just a tad inaccurate, however it is much quicker. The micrometer and bore gauge method was a little more accurate, so it is up to you what you decide to use. If you want to use the micrometer method, you will need to also purchase a 1 to 2 inch micrometer, and you can use the same dial bore gauge as before. Another tool that most people gloss over when building their engine is the socket you need to install your ARP head stud nuts. Most people will find that due to the design of the cylinder head that you can't fit most sockets down to torque the nuts for the ARP head studs. I bought all sorts of half-inch sockets to see which would fit, and found that the Craftsman 12.3/8 inch drive socket works great in the half-inch size. Another tool I believe you will need is a hex head socket kit. This is only for my boys rocking the VVTi engine, as you'll need a hex socket to torque the VVTi cam pulley. You're also going to need assembly lube, but you can really get any brand that you want. I went with the cheap stuff, but generally anything is going to work. The last thing I can think of needing is about 2 tubes of Toyota Fippage, which is their brand of RTV sealant. This stuff is used all over the engine, and I have multiple tubes just laying around my garage. It's great stuff. So this wraps it up for all the specialty tools you'll need to build a 2JZ. This is assuming that you probably already have a basic set of hand tools in your garage, such as socket sets, wrenches, and stuff like that. I hope that everybody learned a thing or two, and for people thinking about building their own engine, I hope this kind of paved the way for all the planning that you're about to do. So if you are planning on building an engine, good luck, and feel free, like I said before, to put any questions you have below or reach out to me directly. Alright guys, have a good one. See you later.